Module 4, Lesson 6, the order of operations. Continuing to look at our learning targets for this module for us to be able to represent real-life situations and be able to compare expressions and experiment. We have to be familiar with the order of operations, and this of course builds a bit on the relationships that we've already established in prior lessons. Specifically for today's lesson, wanting to be able to show and explain that expressions that simplify to one number are numerical expressions, and secondly, evaluate or simplify numerical expressions using the order of operations. So taking a quick look here, a quick review, we would expand our exponents out 3 times 3 times 3 times 3 times 3, and we would multiply all those 3's together. 3 times 3 is 9, times 3 is 27, times 3 more is 81, times 3 more, pretty sure that gets us 243. And we could do that with all of these different problems. So numerical expression, kind of a new vocabulary word here. A numerical expression is a number, or it is any combination of sums, differences, products, divisions of numbers, that when we evaluate it, we will get it to a single number. The value of the numerical expression is the number that we find when we perform all of the operations. So for example, 1/3 times, and we've got parentheses, 2 plus 4 plus 7, that's a numerical expression. When we perform all of these operations, we find that the value is 9. So numerical expressions, when we perform all the operations, we are left with a single number. So then the trick becomes, or the question becomes, how do we perform all of these operations the right way to get the right value? So pause and think about this for a moment. How would you evaluate 3 plus 4 times 2? Of course, the first question is it a numerical expression? Well, it looks to me like all I have here are numbers and operations, so in my mind I'm saying yes, this should evaluate to being a numerical expression. When I'm done, I should get a single number. So take a moment to draw and explain how you would evaluate this, and when you're ready, unpause the video and continue. So there are a couple of different ways that you can think about this problem. Here we've got our 3, and we've added 4 to it, and now we've multiplied by 2. And that would tell us that the value of this numerical expression would be 14. We had the 3, we added 4 more, and then we doubled it, multiplied by 2. So added the 3 plus 4 first for a sum of 7, multiplied 7 times 2 for a product of 14. Here's a different model. So here we've got the 4, and we've multiplied it by 2, and then we have added 3 more. So the value would be 11. So multiplied the 4 times 2 first, and then combined in the 3. So we had 8 plus 3 for a sum of 11. Now, right about now, your brain should be screaming at you saying, wait a minute, wait a minute, wait a minute. I did both of these problems. I know that I did the math right. I know that 3 plus 4 is 7, times 2 is 14. I know that 4 times 2 is 8, and I added the 3. I know that's 11. How is it possible, when I have done these problems correctly, to get 2 different values? So when we evaluate an expression, how many answers should there be? Well, there should be 1. And if there's only 1 value of the expression, what do we need to find that value? We're going to need a set of rules so that we all agree on how we're going to solve this problem together. So we're going to walk through the order of operations. So let's kind of think back in our lives here. What were the first operations you learned about? What were the first operations that we discussed as we started this module? Now hopefully your brain said, you know, when I started out, you know, kindergarten, maybe even before kindergarten, started learning about addition and subtraction. We started putting things together, taking things apart. Now, why do you think you learned about addition and subtraction first? Stop and think about that for a second. Well, most people would say, or many people would say, well, they're simple. They're the least complicated. I can very easily see things being combined. I can very easily see things being taken away or compared. So what is the relationship between addition and subtraction? And we, of course, spent a whole lesson on this. They're inverse operations. They're opposites of each other. Addition can be thought of as counting on, and subtraction can be thought of as counting off or counting back. So after addition and subtraction, what operations did you learn about next? This probably started in maybe late second grade, third grade, fourth grade. Learned about multiplication and division. And what is the relationship between multiplication and division? Well, your brain should scream at you, hey, they're inverse operations, they're opposites. Multiplication can be thought of as repeatedly adding on, although we talked about there being a comparison also in there. But for today, let's just think of it as repeatedly adding on. And division can be thought of as repeatedly subtracting. So then we talked about the relationship between subtraction and multiplication and division. Well, multiplication and division are powerful versions of addition and subtraction. So they're addition and subtraction with really big batteries, being able to have a whole lot more power to them. And it's this relationship that multiplication and division are more powerful versions of addition and subtraction that helps form the foundation of the order of operations. So if division and multiplication are more powerful versions of subtraction and addition, which ones do you think mathematicians decided should be performed first? Well, they decided we should do division and multiplication first. And after division and multiplication, we should perform subtraction and addition. So we need to think of the order of operations as having levels. So for the illustration below, we start at the top level and we work our way down through the levels. And so far we have discussed two levels of the order of operations. Division and multiplication occupy one level together. Subtraction and addition occupy a second level together. Now I put in a big note here, bold, italicized. It is very important to know that the operations on the same level are of equal importance. Division is not more important or more powerful than multiplication. Multiplication is not more powerful or more important than division. Same for subtraction and addition. We do not perform one of the operations before the other operation on the level. We don't go through and say, I've got to do all the division first and then I've got to do all the multiplication. They're on the same level. So we're going to have a specific phrase that we're going to use to help us remember that neither of them is more important, that they're on the same level. And we'll get to that in a few minutes. So I want to take a look again at our models from the opening. And we've got Model 1 and Model 2 with the same explanation. So take a moment and evaluate here which of the two models follows the order of operations. Which one did the more powerful operations first and then moved on to the less powerful operations? Well, hopefully you said, hey, that's Model 2 because it completes the more powerful operation of multiplication first. We doubled the 4 times 2, and then we added on the 3. So with addition, we are finding the sum of two addends. We're adding two numbers together. And in this example, the first addend is the number 3. The second addend happens to be the number that is the value of the expression 4 times 2. So before we can add, we have to determine the value of the second addend. So really trying to look at this problem and say we have two parts to it. We've got the 4 times 2 part and we've got the 3 part. And we can't do the add part until we know what we're actually adding. We can't add until we know the value of the 4 times 2. So, what operations do we evaluate first? Just talked about it. Division or multiplication. And I really want to emphasize the word or. So how are you going to decide what to do first, division or multiplication? Because we've said that they're equally important, but somehow we have to decide what happens first. We're going to read the expression from left to right. And then we're going to perform division or multiplication as we come to them. So for example, if I've got 2 divided by 4 times 3, I'm going to start on the left-hand side, and I'm going to go until I get to the division symbol, and then I will perform the division operation. I'll have 2 divided by 4 times 3. And then I'll start on the left again, and I will go until I get to the multiplication operation, and then I will do the multiplication and get 6/4. So how I like to say this is I go left to right, and then I divide or multiply. Whichever one I come to first is the operation that I perform. Left to right, divide or multiply. Now, what operations do we perform last? Well, after we've taken care of all the multiplication and all the division, after we've done left to right for those, then we're left with our subtraction or our addition. And it's, notice the or, and it's the same question. Well, how do I decide which one I'm going to do first? And that should say subtraction or addition. I'll have to fix that. Well, same way. I go left to right. I start on the left-hand side, and I come in and say, oh, I've got a subtraction symbol first. I'm going to do that. I'll get a -1, and then I've got the +5, which would yield a 4. I go left to right, performing subtraction or addition as I come to them. I don't go through and find all the subtraction and do those first, and then go through and find all the addition and do those first. I go left to right, and whatever I come to first, I take care of that. So first, go left to right, divide or multiply. When I've done all of those, then I move to the next level, go left to right, subtract or add. So take a quick look at this model here. We are asked to evaluate it. I'm asking you to justify your solution with a model, and can you also state whether or not this is a numerical expression? Now in my head, I've already decided, you know what, yes, this is a numerical expression. I don't see any variables in here. All I see are numbers and operations. I'm going to draw the model real quickly here. I see that I've got a 2 times 7, and I know that I am going to do division or multiplication before I do any subtraction or addition. So I need to model the 2 times 7. 1, 2, 3, 4, 5, 6. So there are 7, and now I've got 2 times 7. So I've got that part. On the side here, I'm going to show my work. 4 plus 2 times 7. I just did the 2 times 7 and found that I got 14. And so the next part that I need to perform here is adding the 4. 1, 2, 3. So altogether, I have 18. 2 times 7 is 14, plus 4 more is 18. I'm not going to draw the model for exercise 2, but I will walk through the steps. Drawing the models can be a powerful way of seeing what is happening in these problems. I'm also going to make the prediction that, yes, I think this is a numerical expression. All I see here are numbers and operations. I don't see any variables. So I'm going to start on the left-hand side, and I'm going to go until I get a division or multiplication. I'm going to start there. I've got 36 divided by 3. 36 divided by 3 gives me 12. And then I've got times 4, so I'm going to go left to right. and I get to the multiplication symbol and get 48. Once again, I'm not going to draw the model, but I will walk through showing my work here. Having a tough time, that looks to me like a subtraction symbol. So I'm going to look for division or multiplication first. I've got the 5 times 2, which yields the 10, and I've got the 20 minus 10, which yields 10. Yes, it is a numerical expression. When I was done simplifying, I had one single number. Now, don't allow yourself to get fooled saying, well, this is 2 numbers. No, there's 2 digits there, but together they combine to make one number. I have 0 in the ones place and a 1 in the tens place to make a 10. 10 is a single number. All right, so we've looked at division or multiplication. We've looked at subtraction or addition. We've looked at those 2 levels of the order of operations. But in our last lesson, we learned about exponents. And exponents are a way of writing repeated multiplication. Now, if exponents are more powerful than division, where do you think they fit within the order of operations? Well, they are more powerful. So they are going to be evaluated before any multiplication or division. So we're adding a new level to our order of operations. So when we evaluate expressions, we have to agree to use one set of rules so we all arrive at the same answer. And we're going to do the most powerful operation first. And exponents are more powerful than multiplication or division. So we will start with exponents. Then we will go left to right, divide or multiply. And then we will go left to right, subtract or add. So taking a look at this expression here. Now I'm going to do a quick check here. I think it's numerical. I don't see any variables. All I see are just the operations and the numbers. So I don't see any exponents. So I'm going to go left to right, and I'm going to look for division or multiplication. So start on the left-hand side. That's addition. Nope, going to keep going. Hey, there's a multiplication. I've got 6 times 6, which makes 36. Now, hopefully you're paying attention to how I'm carefully showing my work on each of the steps. So once again, I've got division. I need to start on the left-hand side here, and I am looking for any division or multiplication. And I've got 36 divided by 8. So I need to, off on the side here, 36 divided by 8, 4 times 8 is 32. So I'm going to get 4.5. So I've got 4 plus 4.5. And now I can go left to right. I don't see any more multiplication or division. So I'm going to go left to right, and I'm going to look for any subtraction or addition. And I've got an addition right there, and I end up with 8.5. Now you might be asking yourself, well, what does this have to do with exponents? Well, this same problem could be rewritten using an exponent. We have 6 times 6 here in the middle. And 6 times 6 could be written as 6 squared. So following that order of operations that we just talked about, exponents are a more powerful form of multiplication, so I need to evaluate the exponent first. So 6 times 6 is 36. So I have evaluated the exponent. And now I can go left to right looking for division or multiplication. There's the 36 divided by 8, which we just figured out was 4.5. And we can combine together and get 8.5. Now it's really important that we notice that right here we got the same answer. We followed the order of operations, and even though the problems looked differently, they have the same meaning. So first step, why was it 6 raised to the power of 2? Because the order of operations says do the exponents first. Why the exponents? The exponents are a more powerful form of multiplication. So let's take a walk through on this problem here. What operation are we going to evaluate first? Well, taking a look through here, I notice I've got an exponent. So the first thing I need to do is figure out the 9 squared, which is 9 times 9, which is 81. And then what would come next? Well, I'm going to off on the side here, write this out. There we go. Well, going left to right, looking for division or multiplication, I've got the 81 divided by 3. So I've got 4 plus 27 times 2 minus 2. And then I can do the multiplication. 4 plus 54 minus 2. So I've gone left to right. I've simplified out the division and the multiplication. And I am left with just addition or subtraction. So next I would go left to right, adding and subtracting. So, or subtracting or adding. 4 plus 54 is 58 minus 2, which yields 56. So the value of this numerical expression is 56. All right, so showing your work, and I've walked you through this before, but I want to emphasize how important it is that you actually show all of your work. So the first thing we've got in this problem is we've got some exponents. So somewhere I would expect that you will actually show writing out the exponent in expanded form and then showing how you simplified. So the 3 cubed becomes 27 times 5 minus, and then I've got 2 cubed. And 2 times 2 is 4, times 2 more is 8. So minus 8 divided by 2 plus 4. Now I go left to right, and I am looking for division or multiplication. And I've got 27 times 5, and I would expect that you would show 27 times 5. 135 minus. Now I could stop and simplify the 8 divided by 2. Now there are some 8 divided by 2. If you do that one in your head, I totally get it. 8 divided by 2 is 4 plus 4. So I've simplified all the multiplication and division. And now I'm going to go left to right, and I'm going to look for subtraction or addition. So I've got 135 minus 4, which is 131, plus 4. And of course, I've turned right around and added that 4 back on, 135. So to a certain degree, I should have looked and said, hey, we practiced that clear back in lesson 1 of this module. Took away 4, added 4. I am going to end up with 135. I want to see your work. So if you're making mistakes, I can look and say, oh, I see where that's at. I can help him out with that. With no work, it's really hard to know. All right, so exercise 4. I'm going to go through and evaluate, show all your work. Is this a numerical expression? Well, I notice that all I have are numbers and operations, which means that, yeah, I'm probably going to have a numerical expression here. It's going to simplify down to one value. So first thing I've got in here is some exponents. So 5 squared would yield a 25. I've got 90 minus 25 times 3. I still have some multiplication to take care of, so I'm going to go left to right here and check this out. Left to right, yep, that's my first multiplication. 25 times 3 gives me a 75. 90 minus 75 will yield a 15. All right, taking a look at this one. So we've got an exponent, so 4 times 4 times 4. 4 times 4 is 16 times 4 will give us 64. So 64 plus 2 times 8. 2 times 8 would give us 16. 64 plus 16 will make 80. Now you'll notice that I'm not even talking the order of operations out loud at this point. I've done so many of them, it's very fluent in my mind. You may want to talk yourself through. Okay, first I need to check the exponents. All right, I'm going to check the exponents. All right, next I'm going to go left to right, and I'm going to look for division or multiplication and go through the process. All right, I've got all the division and multiplication done. Okay, I'm now going to go left to right, and I'm going to look for subtraction or addition. Talk yourself through this process so that it becomes fluent to you. All right, the last rule of the order of operations involves grouping symbols. And you have been exposed to these before. Usually when we talk about grouping symbols, it's parentheses. I know that you've been introduced to brackets and braces, but that's not something that's commonly used. Usually you wind up just using lots of sets of parentheses. Now the parentheses tell us about special cases, special examples, certain circumstances. So there are times when we need to do things out of the usual order. Maybe we are supposed to add this together first and then we're supposed to multiply. And the parentheses tell us that. They tell us, do this part first. Operations inside our grouping symbols, parentheses, brackets, and braces, are performed before we deal with any exponents or anything else. And here is an example of how this would work. So a family of 4 is going to go to a soccer game. The tickets are $5 each, and the mom is going to buy herself a soft drink for $2. So stop and think about how you'd write this expression. And if you need to, draw a model of it. Well, we've got 4 people, each needing a ticket for $5, so we could do 4 times 5 for the tickets, and then we would add $2 for mom's soft drink. And that would tell us that the total outing would cost $22. Now, a model of this situation, well, there's the first person's ticket for $5. Here's the second person's ticket for $5. Here's a third ticket for $5. And here's a fourth ticket for $5. So there's our 4 times 5, how much we'll spend for tickets. And then we're going to add $2 for mom's soft drink. So there's our $22. Well, how about we have the same family go to the game as before, but this time each of the family members wants a drink. And the tickets are still $5, the drinks are still $2. So how is the situation different than last situation? Well, instead of just adding $2 for a drink, we've got 4 people getting a drink. So we need to include 4 drinks rather than 1. Instead of just adding $2, we have to do a little bit more in the way of operations. Now there are a couple of models that we can draw of this situation. In your head, think your way through what you would draw. So here's a first model. So here I've got the $5 for the ticket, and $5 for a second ticket, and $5 for a third ticket, and $5 for a fourth ticket. So what expression would go with that? Well, I just did 4 groups of 5. So I paid for the tickets. Then I could spend $2 on a drink, $2 on a drink, $2 on a drink, and $2 on a drink. And that would be the expression that I would write for that. And then I would say that I want to combine all of this. So this is one way that I could write out an expression, draw a model of what is happening. But I'd like you to notice that we're multiplying by 4 twice here. Let's take a look at a second model. The first person gets their ticket and spends $2 on their drink. Second person gets their ticket and spends $2 on their drink. Third person gets their ticket, gets their drink. Fourth person gets their ticket and gets their drink. Now let's stop and think about what was actually happening in this problem. Well, the first person got their ticket and then they got their drink. And we repeated this process 4 times. So instead of writing the 4 twice, I'm able to say, hey, just combine the 5 and the 2 and then multiply it times 4. So some expressions that we can write to represent these models, and we've already looked at these. If you need to, pause and think about those for a second. Both of them are going to show how much we spent. But they are 2 different ways of thinking of the problems. And in particular, this expression here shows the power of using the parentheses. Combine the 5 and the 2 first and then multiply times 4. This expression, we're finding the same value, but we're not doing it with parentheses. We are, however, multiplying by 4 twice. So something else to know about parentheses. What happens if there's 2 sets of parentheses? So for example, in this problem, I've got this is paired with this, and I've got this paired with this. Well, when we have more than one set of parentheses, we start from the inside out. So the very first thing we do is we find the parentheses that are the most inside, which is this one and this one. And you'll notice that parentheses come in pairs. There's always 2 parentheses in a group. So the first thing we would do is evaluate C minus D. Then we would take care of B plus whatever we got when we did C minus D. And then we would multiply A times whatever we got inside here. So we start on the inside, work our way outward. So here are the order of operations. Parentheses, brackets, and braces from the inside out. Then we move to our exponents. Then we go left to right, dividing or multiplying. Then we go left to right, subtracting or adding. You're going to want to commit this to memory. It should be one of those things that you just know. So let's take a moment and look at this exercise here. We're supposed to evaluate, show all our work, and we're answering the question, is it a numerical expression? Well, I don't see any variables. So by the time I have performed all of the operations, I should have a single number. So first is the parentheses. I need to take care of what is inside here first. So I've got 9 squared minus 4. Now inside the parentheses, I follow the order of operations. So I'll do the exponent first. 9 times 9 will give me an 81. So I've got 81 minus 4, which will give me 77. So now I can come back over here, 2 plus 77. There's no more division, there's no more multiplication. I can go left to right looking for subtraction or addition. 2 plus 77 gives me 79. Here's one that's got 2 sets of parentheses. Remember that with parentheses, we start with the inside out. So I've got to go clear inside here. I've got these 2 are a pair, and then I've got these 2 are a pair. So I'm going to do the 3 plus 4 first. So 2 times 13 plus 5 minus 14 divided by 3 plus 4 is 7. And you'll notice that this pair of parentheses went away because I have simplified what is inside. Now I have to perform the order of operations within the parentheses. So 2 times 13 plus 5 minus, and 14 divided by 7 will yield a 2. Inside the parentheses, I've got no more multiplication or division. And so now I can go left to right looking for subtraction or addition. 2 times 13 plus 5 is 18 minus 2. 2 times 16, and all of this together will yield 32. Now there is a little something you've got to pay attention to with exponents. It's a small thing, but people get in a hurry and they sometimes miss this. So take a look at these 2 expressions. What is an observation that you make? Well, in this first expression, I've got an exponent inside the parentheses. And in this expression, I've got an exponent outside the parentheses. Now, are these 2 expressions going to have the same value? Why or why not? Think that through for a minute. And then go ahead and evaluate the 2 expressions following the order of operations. So times 3 and 4 times 4 will give me a 16. 2 times 19, which will yield a 38. Over here, I'm supposed to perform the operation inside parentheses first. So 2 times 7, and the exponent is going to be attached to what I got out of the parentheses. So 2 times and 7 squared is 49. So 2 times 49, which would give me 98. So they definitely did not have the same value, and it comes back to the order of operations. This exponent, this squared right here, goes only with the 4. This squared goes with everything inside those parentheses. So no, they definitely don't have the same value. So what are some conclusions you can draw about evaluating expressions with parentheses and exponents? We have to do what's in the parentheses first. Sometimes there's going to be values with exponents inside the parentheses. If the exponent is outside of the parentheses, do everything inside the parentheses first, and then deal with the exponent. So follow the order of operations. So take a moment and evaluate this. Seven plus 3 yields a 10. And yeah, that's a numerical expression. And here they've moved the exponent to the outside. 7 plus 9 squared. 7 plus 81, which will yield an 88. So having the exponent on the outside is very different than having it on the inside. All right, lesson summary. We've been through a lot here. When we evaluate expressions, we're going to use one set of rules so that everyone arrives at the same correct answer. The order of operations is something that mathematicians agree upon. Grouping symbols like parentheses, we take care of them first. And then we're going to do based on powerful operations. So the parentheses is our first thing. Then our next most powerful is our exponents. And then we've got multiplication, division, going from left to right. And finally, we've got our least powerful operations, addition and subtraction, going from left to right. Memorize it, commit it to memory. All right, so numerical expression is a number, or it's a combination of sums, difference, products, or divisions that evaluates to a number. The value is that number that we get. So, hopefully, you can evaluate numerical expressions using the order of operations. Hopefully, you can also identify numerical expressions. This is a big step toward being able to accomplish our other goals within this module. And this definitely shows yet more relationship between the operations. So at this point, go ahead and work on your problem set. And if you have questions, make sure you talk to your teacher.